Hi, another video about stem and leaf plots and box plots and outliers and standard deviation. So the stem and leaf chart represents the scores of 21 students from a mathematics examination. Okay, so here this first one means 25 if you follow the key. Determine the median as well as the lower and upper quartiles for the given data set. Following this, compute the lower and upper limits for identifying any outliers and assess whether any value qualifies as an outlier. Hence, create a box plot for this data set on the graph paper. For this data set, the sum of x is 1,222 and the sum of x squared is 73,876. Calculate the mean and the standard deviation. Okay, so there's going to be quite a lot in this video. It's going to be quite a long one. So a good idea if you've got a stem and leaf plot is to work out the cumulative frequency. So that's 1. That'll still be 1 because there's nothing in the 30s. Then we're going to add another 3, 4. You get the idea. 11, 17, and 21. Right. So there are 21 values, and therefore the median is the 11th value. So we can identify that one straight away. So we'll put a little circle around that, which is the 59, 5 and 9. Now, to find the lower quartile, okay, is that you look at the lower 10 values and take the median of those. However, if there are two medians, you need to include the lower one of the medians as well when you do this. So just bear that in mind. So in this case, we only have one median, so therefore we just take the median of the 10 values below. So we're going to be looking for the 5th and the 6th values, which are these two here. Notice there's 4 here and 4 above. Okay, so that's going to be Q1 50 plus 52 divided by 2. So we take the average of those two, which is 51. And then we will do the upper quartile. Okay, same idea. If there are two medians, then you need to include the higher value of the medians, but here we don't. We just have one, so we'll just look at the top 10 here. And so Q3 would take the median of the upper 10 values, which are these here, and that will be the 16th and the 17th values. Okay, notice we have 4 before and 4 after. So we're going to have 66 plus 68 divided by 2, which is 67. Right, we're now in a situation where we can actually work out what the lower limit for the outliers is going to be. So first we'll need to work out the interquartile range. That's just Q3 minus Q1. A little correction there, so it's Q1. So it's going to be 67 minus 51, which is going to be 16. Now, to find the outliers, for the lower bound, we do Q1 minus 1.5 times IQR, the interquartile range. So that's going to be 51 minus 1.5 times 16, which will give me 27. Therefore, we can see that 25, statistically, will be an outlier. Therefore, 25 is an outlier. The upper bound will be Q3 plus 1.5 times the interquartile range. So that's going to be 67 plus 1.5 times 16, which will give me 91. Well, we don't have any outliers here outside 91. So no outliers for the upper bound. Okay, so there's only going to be one outlier, which is going to be 25. Right, we're now in a situation where we have to draw the box plot. Now, because we have an outlier, the lowest value is now going to be 45, this one here. To bear that in mind when we draw the box and whisker plot, okay? So it's Q1 and Q2, Q3, and the upper value. We can draw there was one outlier at 25, so drawing the box plot, and I did this one on GeoGebra. Okay, so we will need to put an X here. So this is the box plots for those values. We'll just explain which one is. The lowest value is this whisker here. This is the lower quartile, Q1. This one is the median, Q2. This one is Q3, which is the upper quartile, and this is the highest value here. Now we've got a little x down here at 25, so remember 25 was the outlier, so that's how we represent outliers. Okay, so normally you don't need to put these values on your box and whisker plot. Right, so calculating the mean and the standard deviation, bearing in mind that this video is for the MEI exam board. So we were given that sigma x is 1222 and sigma x squared is 73876. So, and n will be 21. So the mean is the sum of x divided by n. So we just need to do 122 divided by 21, which will give me 58.190, and then correct to 3 symmetric figures, 58.2. This is the formula for the standard deviation. You can't quite see the line across the top here, so I'll draw it in. So we're clear it's the square root of all of this. So it's a square root of sigma x squared minus the number of terms times the mean squared divided by n minus 1 for the MEI board. This is called the sample standard deviation. So check what formulas used for your board. Okay, it is actually worth learning this, although you can get it from the formula sheet, and I will show you later. That's going to be the square root of 73,876 minus 21. Now, here, making sure I don't use a rounded off value, I just use the fraction value. And if you've got that in your calculator, you can just press the answer button on your calculator. Divided by 21 minus 1, that will give you 11.762 ... which is 11.8. Now, like I said, if you use the formula booklet for the standard deviation, MEI, this is what's given in the formula booklet, which is quite horrendous, but it actually is not that bad if you think about it. Okay, so here is our formula. So this bit here, underneath in the numerator, you can get from here. Okay, the divided by n minus 1 you can get from here. And then you'll need to remember to take the square root of it to get the standard deviation. All right, because this divided by this will give you what's known as the sample variance. Okay, but this is actually what is written on the formula booklet. So learn to recognize it and remember that's what you need for the standard deviation. Just one final thing, there's a GeoGebra app to go with this video, which will be in the notes of the video, but you can get from the statistics from this data. So basically I just put every single value into a spreadsheet from the stem and leaf plot. There's 21 items. You can check all these values that we've got here are correct. Okay. Notice though, it does give you the minimum value as 25, so you would have to recognize that 25 is an outlier. Okay, so the software will actually do a box plot with the outlier, which is this one here. You can see the outlier here, and you can also do the box plot. I found out that you can also draw the box plot without the outlier. Obviously, you can see there's much of a tail over here. Okay, so this has been quite a long video to show you how to calculate, to use a stem and leaf plot to draw a box plot, find any outliers, and then also to calculate the mean and the standard deviation. So there's quite a lot covered there in the MEI statistics part of the A-level. I hope you've found the video useful. Please consider subscribing to my channel, and I will put the link of this GeoGebra applet in the notes of the video, and the link to my website where you'll find thousands of videos to help you with A-level maths. Thank you very much for watching.